Hi, hello there. So today is going to be a walkthrough of all the financial maths. So we'll start off with the freshest one. Olga, Shen, Fiona, and Rowan all have bank accounts. Olga puts 3 grand in the savings account. The interest is added annually at 2.4%. Work out the amount in Olga's account after 5 years. So she's just putting in 3 grand. So she's just putting in 3 grand. Then obviously final amount is equal to principal or starting amount times 1 plus I to the power of t. So let's put in our numbers. Our final amount is going to be equal to 3,000 bracket 1 plus, we need I as a decimal, so 2.4% is 0.024 to the power of t, which is 5. So let's get our calculator out for that one. That's going to be 2,000 bracket 1 plus 0.024 to the power of 5, and we need that to the nearest cent. That's going to be 37770, which is equal to 33770. Okay, so there you go. Straightforward junior cert. Explain what is meant by the present value of a payment of €1,000 in 1 year's time at a particular interest rate. Okay, so a present value of 1,000 is the amount, so suppose write it in English, it's the amount that should be invested now at a particular rate in order to generate in order to be €1,000 in this case 1 year's time. So in other words, what do I need to put in? So if you had told me in the previous question 37770, I'd be asking you what would be the present value of that in a year's time, or in 5 years' time, and it would have been 3 grand, that type of thing. Okay, and then obviously there's a question following on that. Shen puts a different amount in a savings account with the same interest rate. After 6 years, he has 4 grand in the account. Work out how much he initially would have had to put in. Okay, so let's see, same interest savings account. So 4 grand, suppose we start at the end, 4,000 is equal to some amount, what is it, 1.024 to the power of, was it 5 years? Oh, 6 years. So Shen had it in for 6 years. So we just need to rearrange this. So obviously 4,000, divide both sides by that, divided by 1.024 to the power 6 is going to be the amount, and that's going to be 4,000 divided by, in a bracket, 1.024 to the power of 6, and that's going to be equal to 3,469 to the nearest cent, 45. Okay, so that's what he would have had to put in now in order to generate 4 grand after 6 years at 2.4% per annum. Okay, simple enough. Nothing too kind of complicated on that one. So far there's been nothing kind of jumping out and saying, ooh, that's a toughie. Right, so let's see what they're going to ask us next. Fiona. So Fiona is one of these quattro. Fiona is taking out a loan at the same interest rate. Fiona makes payments quarterly. Okay, there are 4 quarters in a year. It's written there for you just in case you didn't get it. Work out the quarterly interest rate that it'd be. So if it's 2.4 per year, that's 0.024 per year. Now, if it was 12 months, you'd be 1/12 of a root, but it's quarterly, so it's 1/4 of a root. So we're going to get 1/4, the fourth root of 1.024, and we're going to subtract the 1 from it because we're taking 1 away from it. So that's what we're going to do. And if this is 12, it'd be 12, it's usually 12, but they've started doing this quarterly thing. So on your calculator, shift, put in your 4, put in 1.024, and then come out of your fraction, or come out of your root and press 1. So I don't like the way my calculator does it. I need to reset it up. But basically that's, 0.59%. So it's 0.59. Yeah, it is 0.59%, or 0.0059. That's what it is. So that's a nice one. Now, the fourth lad, Rowan. Rowan wants to put the same amount of money in a savings account at the start of each month for 36 months, so that at the end of 3 years, he will have 12 grand in the account. The interest rate is calculated at a rate of 0.11%. Okay, so it's not 1%, it's 0.11%. So in decimal form, 0011. That's what that is. Taking A to be the amount that he puts into his account at the start of each month, write down a geometric sequence in A to show the total amount of money in the account at the end of 3 years. Okay, so let's do it. We don't know how much he's putting in, but we do know it's going to be A times 1.0011. Okay, for the first month. And then that'll accumulate over 36, and then he'll do it again for the second month. But this will only be accumulating for 35 months, and so on until the very last month. To the power of 1. So that's what he's going to do. Okay? Now, include the first two terms and the last two terms. So sorry, I'm going to have to put a dot there. Didn't read that. A squared. So it's a bit tight there, but you can see what I'm doing. So there's a lot of dots in between that one and that one. Okay, there's a huge gap between those two. Okay, so that's your sequence. That's what he needs to put down. Find A for that number. Okay, so we need to figure out what the A is going to be for that number. So all I know is that when I add all them up, that the A is going to be constant, really. So it's really just going to be, let's work out our SN formula. What is our A going to be? It's going to be A times, well, we've got 1.0011, so that's the first term. There's your A, and there's that first term. Okay, and then on, let's see, we're going to have 1 minus r to the n. And then our n is 36, all over 1 minus r. Now we have to get our calculator out because the answer to this is going to be 12,000. So depending on how you like to do this, you can do it all in one go. You can go 12,000 divided by this. So I'm going to try that and hopefully I'll get the answer. So 12,000 divided by a fraction. And that fraction is 1.0011, 1 minus 1.0011 to the power of 36, close the bracket, over 1 minus 1.0011. And I'm getting €326.60. And to the nearest cent, that works pretty good. Okay, so this answer is going to be €326.60. Okay, so that's a nice one. Okay, nothing too crazy or hard about that one. Now, let's find the next bit of the question. Oh, all right, so the next bit of the question is selling tickets one, an expected value one. So work out the expected value of price of a ticket is 13.85. So how do we work out expected value? It's going to be each number times the percentage. So we're going to have 11 times 52%, 0.52, plus, let me see, 5 less than an adult ticket, times 15%, and there's the adult ticket. So there's the adult ticket, there's 5 less than the adult ticket, and there's 15%, plus, what are we left with here? an adult ticket times 33%, and we know the answer is, what are we, 11, answer is 1385. Right, so let's get our calculator out and help us do a bit of work here. 11 times 0.52, 5.72, plus 0.15x minus 0.15 times 5 is minus 3/4, 0.75 plus 0.33x equal to 13.85. So listen, I'm just going to do this all on the calculator. I'm going to do 13.85. I'm going to take away 5.72, and I'm going to add 0.75. And then that gives me 222 over 25, and then I'm going to add those two and divide that answer over. So I have 0.15 plus 0.33, and then I'm going to divide, so that's 12 over 25x, and that means x is equal to 222 over 25 divided by the answer. So 222 over 25 divided by that answer, and that means x is €18.50. And that's that done. Okay. When an item is being sold, the markup is the profit as a percentage of the cost price. Fair enough. Okay. And the margin is the profit as a percentage of the selling price. A shop sells an item with a margin of 18%. Okay. Work out the markup and give your answer as a percentage. Okay. So suppose the cost price is going to be, if it's 18%, then the cost price is going to be 0.82 of the selling price. Okay? And they're saying that the profit, obviously, the shop sells the item with a margin of 18%. Okay? So the profit is obviously going to be, let me work that, it's going to be 18% of the selling price, 0.18 of the selling price. Okay? And obviously markup is profit as a percentage of cost price. It's these two numbers divided by each other. Okay, so markup is equal to 0.18 over 0.82. 0.18 divided by 0.82. That's, well, to the nearest percent is 22%. Okay, bit of an unusual one, junior certi. Right, have a look at this question. So, a couple agrees to take out a mortgage of 250 grand, purchase a new home. The loans be paid out in monthly over 25 years, and repayment due each month. The annual percentage equivalent to a monthly. So they give you the monthly. Use the amortization, find the monthly repayment. So we want the repayment. Okay? So again, just grab out your formula. Okay? It's not that hard. Okay? The monthly repayment is going to be equal to the principal, which is 250 grand. Bracket the I, which is 0.00287. And then it's 1 plus I, 1.00287 to the power of 25 times 12, which is 300, all over 1 plus I minus 1. 1 plus I to the t minus 1. So that's 1.00287 to the power 300 minus 1. So, you can nearly guess what the answer is going to be, but anyway, let's do it. Fraction 250, bracket 0.00287, close bracket 1.00287, power 300 over 1.00287 to the power 300 minus 1. Should be over 1,000 quid, I'd say. Yeah. So the amount that you're paying back a month is €12.44.06. Okay, not too bad, not too shabby. Okay, now another couple agrees to take out a mortgage of 350 grand at a rate of 0.3%. Okay, so 0.3% is 0.003. Okay, in order to purchase a new home. This loan is also to be paid back over 25 years with repayment due at the end of each month. The amount of each repayment, so they tell you the amount that's due. After 11 years, the couple receive a financial windfall. They decide to repay the remaining balance on the mortgage. Write down a series including the first two and the last two, which shows the total present values of all the remaining monthly repayment due over the 14 years remaining after the last monthly repayment at the end of year 11. Hence, find how much the couple will need to pay in order to clear the mortgage entirely. Okay, this is a bit of a tough one. So, what's going to be the series? It's going to be 1711 over, so remember, f is equal to p bracket 1 plus I to the power of t, but you're rearranging because you want p. So, you're putting f, which is, your repayment, over 1 plus I. So R1 plus I is what? 1.003, okay? Plus, what's the next one? 177 over 1.003 squared, right up to, in our case, what's going to be left here? We've got how many years left after 11 years? So talking 14 years. 14 times 12. 168. So I need to write down the plus 1771 over 1.003 to the 167 plus 1771 over 1.003 to the 168. So there you have the first two and the last two of the remaining 14 years. Okay, so we're going to work out how much that is. Okay, the repayment, let's work out our SN formula. We have an A, we have an R. So A is going to be 1771 over 1.003. We have an R, which is 1 over 1.003, and we have an N, or a T, whichever way you want to call it, 168. So let's pop that all into our formula. 1771 over 1.003 multiplied by, so we've got a fraction in here. We've got, what is it, A bracket R, 1 minus R, N over 1 minus R. Okay, 1 minus R, 1 minus 1 over 1.003 to the power of, what is it, 168 over 1 minus 1 over 1.003. Now, fraction 1771 over 1.003 multiplied by fraction 1 minus 1 over 1.003 to the power 168. I hope I don't need fractions here. Or 1 minus 1 over 1.003. So, and they still owe them €233,438, and we need to round it to the nearest cent, 25 cent. There we go. That's how much they owe them. Still owe them a lot, even after their windfall. Okay? Now, Acme. For those of you who are too young to remember, Acme is the name of the company in all the Looney Tunes cartoons. Acme Confectionery Company has a pension plan. For an employee who qualifies for the full pension, will pay 20 grand on the day of retirement. It will then pay a sum at the same date each subsequent year for the next 25 years. 25 years. Each year, this employee will pay the sum that is 1% more than the amount paid in the previous year. What sum of money must the company set aside on the day of retirement in order to fund this? Assume the annual interest rate is 2.4%. Okay, so the day of retirement, you're going to get 20 grand. Okay. It will then pay a sum on the same date each subsequent year for the next 25 years. Okay, so that 20 grand has been given, so there's another 25 years now where they're going to give them, 20 grand and 1% more, and there's an interest rate on that. So the next one's going to be 20 grand by 1.01% more, and we got 1.024 on this one. And then the next one is going to be 20 grand, 1.01 squared over 1.024 squared, right up to the very last one, which is going to be 20 grand times 1.01 to the power of, we're doing 25 years, aren't we? Over 1.024 to the power of 25. Okay, so there's your sequence. Let's pop our numbers in. Okay, so, you know, you've got your 20 grand. So there's a 20 grand in every one of them. So you can factorize out the 20 grand. Okay, and what are you left with? Well, you're left with 1 plus 1.01 over 1.024 plus the same thing again, 1.01 over 1.024 squared the whole way up. So the only thing that's changing is you've got an A. If we just keep the 20 grand out, then this is an A, and then your R is really going to be that number, because you're multiplying that number by that number to get that, and that number by that number to get that next one. And then N is going to be 26. So it's going to be 20 grand by 1 A bracket 1 minus R to the N, 1 minus R to the N, power of 26, all over 1 minus R. Right. So let's have a look at this. 20,000 multiplied by fraction. That one multiplied by 1 is going to be 1. 1 minus 1.01 over 1.024 to the power of 26 over 1 minus 1.01 over 1.024. And they would have to put aside €440,132 and 40 pence in order to do that, which is quite a lot of money. Quite a lot of money. That's what the government has to do. Well, they don't do it, but they're meant to do it. Okay. Okay. When a loan of P is repaid in equal amounts of A at the end of each term, so there's your amortization formula. In other words, how would you derive this formula? Okay, so we know that when you rearrange your F formula, you get this formula. And then when you add it to the next one, and when you add it to the next one, and so on and so forth. Sorry, that's not 1 plus I cubed, and so on and so forth. That's the way it goes up. Okay, so let's put this into our SN formula. SN is equal to A (1 minus R to the N). R is going to be 1 over 1 plus I over 1 minus R. Okay, so at the end, this is going to be our P. Okay, so that's P is equal to A over 1 plus I. Now, when I bring that N in, that's still 1. When I bring it in there, we get a common denominator on the top of 1 plus I to the N. And on the top here, we get 1 plus I to the N minus 1. Okay? On the bottom of this fraction, common denominator of 1 plus I. And then we got 1 plus I minus 1. So that leaves us on the top, okay, with an A over 1 plus I times 1 plus I to the N minus 1 over 1 plus I to the N all over. They cancel to be just I. Now, as you can see, we've got a fraction situation going on here. So what we can do is multiply the top of this fraction by the bottom number, and it'll cancel those two out. And then the I just gets multiplied in here. So that's really going to be equal to A multiplied by 1 plus I to the n minus 1 over, so that's multiplied up, which means it's cancelled with that, so that's why there's no A there, and the I is just going to get multiplied by that, I times 1 plus I to the n. Okay, so we need to now look at the original one and see how close we are, because remember the P is here now. Okay, so sorry, there it is, P is there now, and we just need to rearrange this. So do I have an I on the top? I don't, so that needs to come up, but I can see it on the bottom, so that bottom must end up being there, and that top must end up being there. So in order to show this, what I'm going to do is I'm going to replace this and this with just two other letters. So imagine that's P is equal to A, B over C. Let's rearrange it to get A on its own. That would give me PC is equal to AB, which means A will be equal to PC over B. Now let's see what the P, C and B are in this case. Okay, so look, P is P, so there you have it. Okay, C, my original C was the bottom of the fraction, so now it's on the top. So you can see this is really going to go on the top, and that's just going to move to the bottom. So really, what happens is A is equal to P multiplied by the bottom, I times 1 plus I to the n over the top, 1 plus I to the n minus 1. And that's how you do it. Okay? Now that you have that done, they want to answer some questions, of course. Alex has a credit card of $5,000. One method of clearing this is to make a fixed repayment at the end of each month. The amount of this repayment is 2.5% the original debt. What is the fixed monthly repayment on $5,000? Well, 5,000 by 2.5% is 125 quid. The annual is 21.7. Find the monthly. Get the 12th root of 1.2175 and then take away 1. So let's get the 12th root, 1.2175, and we'll take away 1. And we get 0.016, which is equal to 1.65%, or 0.0165. Okay? Now, assume Alex has paid this much, complete how much he's left. Okay, so let's figure it out. He's paying a fixed monthly, 125, so they're all going to be 125 because it's fixed. The interest on this one, let me see. So the interest on that one is going to be what are we looking at here? €82.50. Okay, so now let's follow this down. Okay, so we're starting with our new balance. He's paying that. Let's get the percentage of that in there. It reduces the previous balance. So 495750 by 0.0165. So I'm assuming these are done to the nearest cent, 81.80, and that will reduce